Okay, so today we are working on section 4.3, combining functions. And when I say combining functions, I mean by adding, subtracting, and multiplying. So for each of these, this should be problems 1 through 6. We're going to use these functions here below, and these are just random functions that I chose. So for the first one, we're going to do p of x minus q of x. So I've got 3x cubed minus x squared plus 6x minus 2 minus my q of x, which is equal to x squared minus 6. Now, remember that whenever you are subtracting a value within parentheses, that is actually like you're multiplying by -1. So the easiest thing to do, I prefer to add things vertically instead of horizontally. I think it keeps everything kind of more organized and where it needs to be. So I flipped the signs of everything that's in this parentheses, so that would change to -x squared, and I'm going to line it up right under the x squared over here. And then -1 times -6 would be +6, and I'm going to put it under the constant of the first one. Now I can just add them up. So this is where In-N-Out Burger kind of works with this. So if you think of your exponents as the number of patties on the burger, these would be your 3x3s, these are your double-doubles, your singles, and the constants are your milkshakes. And if you think about it like that, then you can just total up how many of each type of burger you have, and then you won't accidentally try to multiply exponents when you're not supposed to. So for this one, we just get 3x cubed minus 2x squared plus 6x plus 4. Okay. F of x plus g of x. We have 2x squared plus x minus 4. G of x is, I'm going to line them right up underneath. So I have 3 and -x squared. So I've got x squared plus x minus 1. Okay. Number 3 I'm going to do over here. I kind of didn't leave enough room for you to put everything where it needed to be. So my p of x is 3x cubed minus x squared plus 6x minus 2. And I'm going to add my f of x function, which is 2x squared. I'm going to put it right underneath, plus x minus 4. You can kind of see why my preference is to add vertically. When things are horizontal like this, I tend to think that things get lost. So my preferred method of multiplying polynomials is not FOIL, and you'll see that in the next section. So let's just add up what we have. We've got 3x cubed plus 2x squared plus 7x minus 6. All right, go ahead and do number 4, 5, and 6 on your own, and then this should be a number 5, not 5H. Do 4, 5, and 6 on your own, and then come back and check your answers, please. Okay, so for number 4, I got x squared minus 4x plus 2. You'll notice what I did here. Since our g of x function, first of all, it's not in standard form because my x squared is not going first. But anytime you have a term missing, there's actually a coefficient for that term. Remember, we talked about that in class. That really there is an x to the first term, but it's really 0x. And that becomes important when we're using synthetic division and synthetic substitution. But also when you're adding and subtracting polynomials, you can save a space for those terms that are missing by adding the 0. So you'll notice on number 4 and 5, I did, actually for the last 3, I did that for all of them. Just to show you can see where they're lining up and that there is actually a coefficient there, it just happens to be a 0. Okay? So for number 5, you should have gotten 3x cubed minus x squared plus 2x plus 3. And number 6, 3x squared plus 5x minus 15. So check those. Hope you got them right. If not, ask me for more practice, and we'll be doing more practice in class. Okay, so multiplying polynomials. And this is a what we're doing with polynomials between the multiplying and dividing them. It's kind of a big deal in algebra, and it's something that follows into further things in pre-calculus and any other math class you take, frankly, into even finite math, business math. These are things that you will learn how to do. So some of you learned FOIL when you first learned how to do this. I actually teach 4 different methods. So you'll see that I teach FOIL, box, vertical, and double distributive. I'm going to do the same problem 4 different ways, and it's up, actually I'm going to do 2 separate problems, and it's up to you to decide which method works for you the best. I have no preference for you. You have to decide which one of these methods works the best, but you need to choose one and use it well. So we're going to use, we can use kind of a complicated one. Let's multiply 7n plus 5 and 4n plus 6. So FOIL stands for first, outer, inner, and last. And that means that we're doing first term to first term, the outer 2 terms together, the inner 2 terms, and the last 2, and that we're multiplying those. So if we take the first 2 terms, we have 7 times 7n times 4n plus, now our outer 2 terms, which would be 7n times 6. You certainly do not need to write it in expanded form. When you're multiplying it, I'm doing that so you have steps and you can see exactly what's going on. Our inner terms would be 5 and 4n, and our outer terms would be 5 and 6. The gist is that you want to make sure that you are multiplying every portion of the parentheses, each term, by every portion of the other term. Okay, of the other binomial, excuse me, each term within the binomial. So let's clean this up. So 7 times 4 is 28, n times n is n squared, and 7n times 6 is 42n. 5 times 4n is 20n, and 5 times 6 is 30. So now we can combine like terms in the middle. We have 28n squared plus 62n plus 30. Okay, now I'm going to do the same exact problem, but I'm going to show you box method. So box method is handy because you can make the box as big or small as you need to. So for every term that you have in each parentheses, you need to make a 1 row, and in the other parentheses, you need to make a column. So this would be a 2 by 2 box. So I'm going to write my box like this, and give yourself room to work. You don't need to make them super small. So each of those terms is going to be written above the box and down the side. It doesn't matter which binomial goes on the top and which one goes down the side, but you need to keep that binomial together. So I couldn't swap out 7n and 6 up here because now I've changed completely the binomial. Okay, so now 4n, it'd be like if I said 47 times 58 and I say, oh, what the heck, I'll just multiply 48 times 57. Well, that's not going to give you the same answer as that, so you can't do that. Okay, so let's do the same thing. So now this is like this is based off the idea of the multiplication tables that you had in elementary school, and you had 1 through 12 across the top and 1 through 12 down the bottom, or sorry, down the side. And then you would say, okay, and 5 times 6 is 30, so it goes into that square right there. So you're doing exactly the same thing, except now it's for a particular polynomial, and we're adding variables into it. So 7n times 4n is going to go in the box right here, and we have 28n squared. 5 times 4n would come here, and that's 20n. And then 6 times 7n would be 42n. And of course we already did 30. So now when you're looking at these, if you have polynomials that are listed from their largest exponent down to their smallest, not missing any terms, what will typically happen is this term will stand alone, so 28n squared. The last term will stand alone, 30. And then these two can be combined because they both share the same variable. So you can combine those together and you would get 62n, which is the same answer we got in the first method. Okay. So now vertical method. So vertical method is kind of based off of this type of multiplication that you've been doing forever. So you know how to multiply one number times another number, right? And you multiply the farthest right on the bottom times both of the numbers on the top. And then you scoot down 1 and over, and you either put a 0 there or a happy face or something, some placeholder there. 3 times 2 is 6, and 3 times 1 is 3. And then you just add them straight down the columns. So vertical method for binomials works off exactly the same principle. So I'm going to take this same problem, and I'm going to have 7n plus 5, and I'm just going to stack them. It doesn't really matter which one you put on top and the bottom. Just like with regular numbers, whichever polynomial is longer is the one I would put on the top. So for example, if you had 212 times 34, you would put the 212 on the top. You would not have the larger number on the bottom typically. Okay. Now you're just going to multiply exactly like you did this. So first you're going to multiply the farthest to the right, the 6, times 5n times 7n. So positive 6 times positive 5 is positive 30. Positive 6 times 7n is 42n. Now you're going to move down 1 and over, so you can put a 0 here if you like, or you can just leave it blank. 4n times 5 is 20n, and 4n times 7n is 28n squared. Now you can see one of the reasons I really like vertical method is because it adds up right down the columns. Everything is in its own category where it should be, lined up nice and clean. I scooted the answer over to the right just a little bit. Okay, but it's exactly where it should be. And in fact, even though I'm over the line a little bit, I'm going to write these right below so nobody's confused about where I'm going with this. So you have 30, 62n, and 28n squared. It's very clean, organized, linear. Everything is exactly where it should be and right where you need it to be. Okay, last method, you can see that we got the same answer as we did above. So the last type is double distributive, and it's exactly what it says. So if you have 7n plus 5 times 4n plus 6, then you're going to separate one of these binomials. Doesn't matter which one. I'm going to go ahead and separate the first one. So I have a 7n and 5. To each one of those, I'm going to multiply it by my other binomial. Okay. So really I'm doing distributive property twice, which is essentially what every multiplication problem is, even when you're doing this, right? I've separated that 34. I'm multiplying the 4 times 12 and then the 30 times 12. And that's exactly what I got. 4 times 12 is 48. 30 times 12 is 360, and then I'm adding them together. Okay, so binomials work the same way. So 7n times 4n is 28n squared, and 7n times 6 is 42n. Go down to the second one. 5 times 4n is 20n. So logically, where do you think I'm going to put that? Would I put it under the n squared? Well, no. I want to line up things that are similar because then it makes my simplifying much easier. So 5 times 4n is 20n, so I'm going to go ahead and put it right under the other n term. And then 5 times 6 is 30. And now you can add just straight down. Okay. So same problem, 4 different ways. I'm going to allow you to choose which way you want to do that. And now I'm going to give you another problem for each of those that I want you to go ahead and shut the video off. Do one problem each, do the same problem 4 different ways, and then kind of put a star next to the one you think you want to use. And I'm going to look for that when I'm checking your notes on Thursday and Friday. So I'm curious to see how many of you want to use each method. So let's go ahead and do 5x plus 8 and 6x plus 3. So for each one of these, I want you to multiply the same 2 binomials each time, but using each method. So go ahead and do that, and then you can come back and check your work and do that now.